Hello viewers, welcome to today's lecture on multimedia services. The advancement of technology has led to the deployment of high-speed networks and also tremendous research in the field of compression has led to the development of powerful compression techniques. As a result, the bandwidth required after compression is small, and networks provides high-speed broadband services. These two together has made many new applications possible. In today's lecture, I shall try to give an overview of the popular applications or services available today for multimedia applications. Here is the outline of today's lecture. First, I shall give a brief introduction and then mention about the popular multimedia services, and they can be categorized into three basic types. First one is streaming stored audio and video. Video on demand is an application. Streaming live audio and video. One application is direct to home, DTH. Then interactive real-time audio video. I shall give examples from teleconferencing and voice over IP. And on completion of this course, of this lecture, the students will be able to state various multimedia applications possible today. They will be able to explain how streaming let me emphasize on this term, stored audio video services such as VOD is provided. They will be able to explain how streaming live audio video services such as TV broadcasting through internet is possible. They will be able to explain how interactive real-time audio video services such as video conferencing and voice over IP are provided. So here is the basic introduction. As I mentioned, the deployment of high-speed networks and reduction in bandwidth requirement because of compression has led to the emergence of diverse applications, diverse and many applications. And these applications can be broadly categorized into three types, as I have mentioned: streaming stored audio video, streaming live audio video, and interactive audio video. And I shall give some examples of these applications such as video on demand, broadcasting of radio TV programs through internet, interactive audio video such as tele or video conferencing, and voice over IP. First, let us focus on streaming stored audio video. The simplest approach of giving this service is to download the compressed audio video files just like a text file by a client, and then the client plays the file. So here the schematic diagram is shown. So first step is, this is the step number 1. In first step, the audio video files are requested by the client through the browser to the web server, and in response the web server sends the file, and after receiving the file, obviously it has to be stored here. This can be played in the third step with the help of a media player. So it involves three basic steps: getting the file from the server by sending a request like get, and getting the response from the web server, then playing it. Now in this, the limitation is the file is bulky even after compression. So as a result, the file will be very large. For example, without compression, the size of a 1 hour MPEG-1 file is 600 megabyte. After compression, it comes to 300 megabyte for VCR quality 1 hour video using MPEG-1. Obviously, to download such a file, it will take quite some time. It may take minutes, sometime hours, depending on the size of the file and the bandwidth of the link through which the downloading is done. So it will take time, it will occupy large storage space in the client system, and then it can be played. So these are the limitation of this streaming stored audio video service. Here of course we are not really doing the streaming, although I have written here streaming stored audio video service. It is being transferred, then it is played. It is not a streaming service that way. Let us now consider the second approach. In second approach, the media player is directly connected to the web server for downloading audio video file. Here what is being done, the browser again sends a request, not really for the file but a meta file. Meta file contains information of the actual file, so the web server sends that response to the browser. Then the media player uses that meta file to interact directly with the web server. Then the web server it sends the media player sends a request like get audio video file to the web server, and in response the web server streams the audio video file, and that can be played here. So in this case the storage requirement is very small. So here we are using essentially two different types of file. First is a meta file and the actual file that is being played and performed in a stream manner. So web server streams the file and sends it to the media player as it plays. So this is how it takes place. Now here the advantage is that the entire file need not be transferred before you can play it. In the previous case we have seen it may take minutes or hours before you can play the file, in spite of the fact that you may have very large storage space, you have to wait. But here it is not so. You can start playing after a short time. Only a small portion will be transferred from the web server to the media player. Then the media player will keep on playing it as it receives the file, actual file from the web server. So this is the advantage of this approach. So the client system need not have very large storage space in this particular case. However, here the limitation is both the browser and media player uses the HTTP for downloading meta file as well as the audio video file. So both the steps, that means all the steps will require the use of HTTP, which runs over TCP. And as we know, TCP is not really a very good protocol to provide this for the purpose of streaming. Because why TCP is not very suitable? The reason is TCP first of all performs flow control, error control, and as a result, if there is some error, some kind of retransmission will be required. That is not a good, that is not supported or required for streaming because of high redundancy present in the files. So it is not really very good approach. That's why the third approach is used, in which case a separate media server is used for downloading audio video file. So in the first step, the client through the browser sends a GET request for the meta file. Then the web server sends the response, and that is being used by that meta file information is sent by the browser to the media player. Then the media player communicates with media server in step 4 and 5, and then the media player communicates with media server to perform the communication. In such a case, it avoids the use of TCP, which is unsuitable for downloading audio video files. So here UTP, it uses UDP, and as you know, that UDP does not support flow control, error control, and so on, which is not really required here. However, UDP alone cannot do the job. It uses other protocols, other support protocols to perform this streaming. So this is a better approach than the previous two, and this is being commonly used for audio video streaming. Now let us consider the application of this streaming stored audio video. The most popular application is the video on demand. We are all familiar with the stores which gives the CDs, that means CDs of movies, on rental basis. We take the CDs to our home, then we can play them. Whenever we want, we can pause, we can stop, or we can replay. Part of the movie can be replayed. We want similar facilities through the internet. Instead of the rental stores, here we shall use the audio video servers to do the job, and only requirement is that we must have a high speed network such as SONET or ATM, and these links are usually fiber optic. As we already know, we have already discussed SONET and ATM, and the servers are connected through high speed network and to some switches, and with the help of these switches there is local distribution network, and this you can have some kind of local spooling server. Through sometimes the files are transferred to the local spooling server, and from that local spooling server it can be broadcasted or sent multicasted to a number of users. For example, we can use different types of local distribution system. For example, that we use in our campuses. For example, it can be LAN in some cases, or it can be some other type of network that can be used for local distribution network. So this is the requirement for video on demand service. So you require a high speed network, and then it is transferred and it goes to the switch, and then distribution is performed. And let me take up an example as a case study, video on demand case study that is being done in IIT Kharagpur campus. We use it, video on demand is being used here for educational purposes. We don't use it for commercial purposes, but for educational purposes. Instead of movies, here we use a number of video courses. There are about 100 video courses which are used as video on demand, and throughout the campus from anywhere the students, faculty members, anybody can access these video cassettes, video courses. Each of them may be 30 to 40 lectures in each of them, each of 1 hour duration. So that is being provided within the IIT Kharagpur campus. For that purpose you require some infrastructural facilities. Let us look at the infrastructure deployed in IIT Kharagpur. First of all, you require high speed LAN, and for residences ADSL network, which you have discussed earlier in detail. We require media servers. These are the hardware required. Of course, you will require some software as well, like operating system. That can be, there are several alternatives, but here Windows 2000 .NET server is being used. Then you require encoding software. Here also there are several alternatives, but Windows Media Encoder is being used here at the server end, and at the user end Windows Media Player is being used. These are being used because these are primarily free and provides good quality audio video above 128 kilobits per second. Let us now focus on the network, the distribution network that in IIT Kharagpur campus. There is a gigabit Ethernet based backbone network. This is the main switch layer. This is a layer 3 switch. Layer 3 switch, gigabit Ethernet switch, which acts as a backbone, and this switch is installed in the computer and informatics center, and from that place through optical fiber link various departments and even all the hostels are connected. So optical fiber links are going to all the departments and all the hostels, and where there are 100 megabits per second switches, that means fast Ethernet switches, and with the help of that it goes to different users or desktops. However, for the residential area the requirement is different. See, the LAN is not that this LAN facility is not extended to the residential area, but with the help of DSL based broadband access, residential the services are provided, broadband services are provided to the residential area. And for that the technology that is being used is the DSLM, which is used as the access provider, is the equipment that really allows DSL to happen. What it does, here there is a box which is shown here, DSLM, which is essentially a multiplexer. This DSLM takes connections from many customers, 12 customers, it goes to 12 residences where there is a DSL modem, and from these the signals from 12 customers are aggregated and are connected to 100 megabit LAN, 100 megabit per second, that means fast Ethernet LAN. And on the other side, to get the audio service, it is connected to the PAVS, where about 2000 line PAVX line is there. So with the help of this, both audio and internet service is available. So essentially our that campus LAN, it is connected to the gigabit Ethernet switch, which is the internet service provider to the residences. So then it comes to the residence, to the ADSL modem, and that ADSL modem, one port goes to the desktop and another port through low pass filter goes to the telephone. So the telephone conversation which is restricted to usually 4 kilobits per second, that does not disturb the data communication through the for the internet access. So both can take place simultaneously, internet access as well as telephone conversation. So with the help of this broadband service available to the residences as well as to the institutional area, that means the hostels, departments and so on, this video on demand service is available. Now let us focus on the media servers that is being necessary. Media servers has to be little powerful in terms of the main memory and the hard disk storage. So media servers typically has got Pentium 4 processor, each with main memory of 1 GB and hard disk drive with RAID 5. RAID 5 means you require 5 hard disks, each of 147 gigabit capacity. So although there are several alternatives, like one can use tape, optical disk drive and magnetic disk controller, most of the course material is stored in hard disk in IIT Kharagpur, and others are not used, but they can be used if necessary. Then let us talk about some important issues related to this video on demand service. It has been observed that all courses, like all movies, if you have say 1000 movies, all of them are not equally popular. Similarly, if you have 100 courses, each of them may not be equally popular. Some are very popular, some are less popular, some are not at all used. So how do you provide better service for the courses which are more widely used? And that can be done in two ways. One possible solution is to use memory hierarchy. As you know, in computer the memory can be hierarchically organized. in say at the top layer you have got the random access memory, which is the costliest. In terms of cost, you can say in this direction. So cost is higher for RAM, cost is lesser for hard disk, red, then it is still lesser for optical disk and still lesser for tape drive. On the other hand, for capacity, it goes in the reverse direction. RAM has lesser capacity than hard disk, optical disk has still higher capacity than the hard disks, and tape archive can have still higher capacity. So what can be done? Some of the courses which are very popular can be stored in hard disks, lesser useful courses can be kept in optical disks, and which are not used, very rarely used, they can be stored in tapes. So in this way one can hierarchically distribute different courses. However, with time the cost of hard disk drives has come down significantly. Nowadays the hard disk drive cost is not very high, so this alternative is not being used in IIT Kharagpur. Instead of that, what is being done, instead of having one media servers, 3 media servers are used, each of the same configuration with the same IP address. So it is transparent to the user. However, the out of these 3 servers, one server is loaded with lesser number of courses. That means the most popular courses are loaded in a server, and the number of courses loaded in that server is fewer. And the second server, the number of courses is a little more, which are usually accessed but not very frequently. And in the third server you can put a large number of courses, but the courses which are not regularly used. So in this way, using 3 servers but storing all the courses in hard disk using RAID 5, it is being done. And use of RAID 5 also provides you higher throughput, which is necessary for streaming purposes. As you can see here, real-time output streams has to meet timing requirements. For example, the kind of encoding that is being done here requires streaming at the rate of 766 kilobit per second to get flicker-free display. As you know, whenever you read some data from disks, it is read in terms of sectors, so in discrete form. On the other hand, whenever it is displayed, it is done in a streamed way, I mean continuous manner. And so what you have to do, you have to use some kind of buffering. So this is how the data is being read. So it is read and one sector is sent, then another sector is read, this is the time required, then another sector is sent, then another, after reading another sector it is being sent here. In this way it goes on. So after buffering for some duration, the transmission starts. So here the play starts, and you can see the play is taking place continuously. So in spite of the fact that the data is received in discrete form in terms of packets, the transmission is taking place continuously to get flicker-free display. So these are the important issues to be remembered in the context of voice over, that means this particular VOD service, voice on demand, video on demand service. So I have discussed in nutshell the requirement for this video on demand service, infrastructure required, you require broadband network, broadband service, then media servers, then the operating system at the server end, and Windows Media Player at the receiving end. So this is how the video on demand is provided for educational purposes in IIT Kharagpur. Now let us come to the next application, that is your streaming live audio video. The streaming live audio video, we are very popular, we are very familiar with the radio stations, TV stations which are continuously transmitting audio and video signals. and with the help of our radio receivers and TV, we can tune to one of the stations, can watch or listen. We listen the radio, songs or news, and similarly you can watch the TV. But what we want here, we want to do it through internet. So whenever we try to do it through internet, that means similar kind of audio and video services, we have to understand the requirement and how it can be supported. First of all, just like the conventional audio video service using radio and TV stations, through internet it is also sensitive to delay, and also retransmission cannot be done whenever we do it through internet. As I have mentioned, because of lot of redundancy, if one frame is discarded, it does not matter, but after this transmission, if that frame comes, we cannot really play it back. So retransmission has to be dismissed, and we have to also understand, in this case communication is really multicast and live. It is not unicast as it happens in case of video on demand. Video on demand is essentially unicast from the media server to from the media server to a particular users. Of course, that media server is simultaneously giving service to a number of users at a time. However, it is usually point to point, unicast in nature. However, in case of live streaming, live audio video, it has to be multicast and live. It is not stored. One example of streaming live audio video is through satellite network. As you know, the program material from studios are sent to a uplink earth station, and through satellite it goes to different network and different those VSAT antennas, and there it is received, and you can have cable TV network, or you can have a transmitter like low power transmitter, LPT or high PT, high power transmitter, which can broadcast, or it can be broadcasted with the help of the cable TV network. As I mentioned earlier, the cable TV network can also be used for distribution of video on demand, but the use of cable TV for video on demand is not popular, particularly in India. So this is one kind of service. So through network it is distributed, then either using LPT or high PT, high power transmitters or low power transmitter, it can be broadcasted. Another possibility is to use cable TV network for distribution. Another new service has been introduced, which is becoming gradually popular, that is direct to home service. Here there is no need for cable TV provider or low power transmitter, high power transmitter is not involved. Through satellite link, each home will have a small antenna, and that antenna can be used to receive the signal from satellite, and we will require one set-top box. With the help of set-top box, it can be played, and the set-top box is essentially a computer. It has got the CPU, ROM, RAM, and through input-output port it goes to TV and a remote control, and in addition to that it has got that MPEG decoder. So the signal that is being received through the network, in this case it is satellite network, it can be other types of network as well. From the network it receives the compressed signal, which is decoded by this MPEG decoder, then it goes to the through the IO it goes to the TV, and you can select different channels and you can configure it in different ways with the help of the remote control. So in the residences you require a small antenna and a set-top box, with the help of which you can have this direct to home service, which provides you this live streaming, live audio video services. Now let us consider the third service, that is real-time interactive audio video. In case of real-time interactive audio video, what we do, you have to first understand the requirement for real-time interactive audio video. First, let us consider the requirements, then we shall discuss how these services are provided and various applications. First of all, let us consider how a client and a server communicates through internet some audio video in real time and interactive manner. Let's assume four files are there, each is holding audio video information of each of 20 seconds, and this is being transmitted through internet, and here it is assumed that the internet takes about 1 second to send the packet from one end to another. Of course, there is propagation time. Here 1 second is the propagation time and 20 seconds is the transmission time of the audio video file. So the server sends the audio video file to the client and where it is played. And let's assume the server has started sending the first file from 000010. This is the 000010 hours. This is the hour, this is the minute, this is the second. So this is your hour, this is your minute, and this is the second. As you already know, this time information is provided by the encoder. That MPEG encoder provides time stamping in each of these packets or files. So with the help of this time stamping, the times are known. So at this time this is being sent and the receiver knows what is the starting time. However, it reaches 1 second later, so immediately after receiving it, it starts playing. So as it starts playing, it will play for 20 seconds, and after 20 seconds it will start receiving the second packet which or second message you can say, which also which has the 20-second information. So information of 20 second audio video information is here, and that comes in between 000031 to 000051. Within this time it takes 20 seconds to receive here and it is plays. That means play is starting 1 second later and then it is continuously being played here in real time. And in this way four files is transferred in real time from the server to the client and it plays there continuously. So here we have assumed that the delay is constant and it takes one time. So so this 1 second delay of the network does not really matter, because here the playback is starting after 1 second and then it is continuously playing it. So it is received and played. So the received and play time is shown here. But unfortunately the network does not have a constant delay, and as we know, the video files are having variable bit rate because of the compression of different files can be of different amount. This will lead to variable bit rate traffic, and as a consequence the files that will be reaching or the messages or information that will be reaching at the client end will be different. That means there will be some variation in delay as it is shown in the next slide. Here let us assume the first file is having a delay of 3 seconds. The second file is having, this one is having a delay of 3 seconds. The second file is reaching after a delay of about 6 seconds. Third file is reaching after a delay of about 10 seconds. So this is 3, this is 6 seconds, this is 10 seconds, and this one is reaching after a delay of about 8 seconds. Now what you have to do, what you can do in such a case? In such a case, in spite of the fact the receiver knows at what time, what is the starting time of each of these packets, since they are received at with different delay, they cannot be played one after the other because of the variation in delay, which leads to, which is known as jitter. How can you overcome this jitter? So apart from the use of these timestamps, the requirement is to use some buffer. What can be done? Before starting these files, they can be buffered for certain duration. Let's assume it is assumed that the maximum delay that can take place is 11 seconds. So what is being done at the receiving end? The first file is played after 21 seconds. So 000021. Sender is sending at 000010, but the first this first file is, I mean, play starts at 000021. However, to do that it is necessary to store the information for information of 8 seconds. What has been received in the 8 seconds? It has received, you know, it has a delay of 3 seconds. So after 11 seconds you have started playing. So 8 seconds of information are to be buffered, and then it starts playing. And as it plays, the other message has come. So that too has to be stored. Usually what can be done, some kind of double buffering can be used. Double buffering. So this file, first file is stored in one buffer, second file is stored in another buffer, third file is stored in another buffer, so that as the first file is played from the first buffer, the information can come to the second buffer because of variable delay, and it can reach here. So you can see here, in spite of the variable delays of 8 seconds, 5 seconds, 3 seconds, 6 seconds, 10 seconds and 8 seconds, it can be played without any jitter if by buffering it and then playing it after 11 seconds. And at different instants of time, you can see at the when the play starts at different points, you can see this is the buffer required. In the first case, information of 8 seconds buffer is required. In the second case, information of 5 seconds buffer is required. In the third case, information of 1 second buffer is required, and so on. So this shows that on the way. This one has been lost on the way. So it has been damaged in such a way, the other side, the receiver side, has not been able to recognize it. What will happen in such a case? So in such a case, the receiver does not know that a particular message packet has been lost. So to overcome that situation, it is necessary to use, in addition to these two, sequence number. So each of these messages are provided with a sequence number. That means if this is provided with sequence number 1, this is provided with sequence number 2, this is provided with sequence number 3, this is provided with sequence number 4. So if the message with sequence number 2 is not received, then the receiver will know that, if 1 is received and then 3 is received and 2 is not received, then the receiver will know that message 3 has not been received. So this is how by using time stamping, buffer and sequence number, it can be played one after the other in a continuous manner without any jitter it can be played, and even as one frame reaches one after the other, I mean suppose this frame reaches later than this one, that also will be taken care of by the sequence number. So these are the facilities required for real-time interactive audio-video transmission, and suitable protocol ought to be used to support this. And one application of this real-time interactive video audio-video is video conferencing. What can be done? Using a network, a camera and a handset, people can interact as if they were talking face to face in a room. Nowadays, if you want to hold a meeting, then you have to go to somewhere to attend the meeting, and possibly people from different parts of the country will come to attend a meeting. But nowadays busy executives don't have time to travel. What can be done in such a case? One can do video conferencing. So it can be done for holding meetings, it can be done for holding interviews. Say a person sitting in Bangalore can take an interview of a person sitting in Calcutta or Kharagpur and talking to each other, and each of them can see each other as if they are talking face to face. So these are the general applications: conducting interviews, holding meetings, setting up meetings, or giving lectures. This has become popular in many universities. The professor sitting in his room can broadcast a lecture, and it can be viewed in different lecture rooms, maybe not only in one campus, in several campuses or in different cities, and it can be done in an interactive manner. So this has become a reality nowadays. And apart from these general applications, another very important application is in telemedicine. A patient in a rural place can take the help or guidance of an expert doctor in a city with the help of this internet by using teleconferencing. So if teleconferencing is deployed in some places, from there one can take, or say from some expert doctor can give advice to a general practitioner for a particular disease, or sometimes an expert surgeon can guide another surgeon from a remote place with the help of this teleconferencing. So these are the various important applications emerging based on this teleconferencing. And there are two types of video conferencing can be done. One is point-to-point conferencing, which is basically a communication link between any two locations. Another is multi-point conferencing, which is a link between a variety of locations. So it will require not only point-to-point, which requires unicast communication, but also multicast, when it has to be multi-point. That means multiple point can join, multiple users can talk to each other. So similarly, video conferencing can be done simultaneously at different places. Nowadays, for example, when we hold conferences, there also use this service. For example, there are two program committees, one in India, another in USA. The two program committee members of USA and program committee members of India can interact by using video conferencing, can hold meetings, and for deciding which papers are to be selected for a particular conference and so on. So this has become very common and widely used. So as I mentioned, to support this real-time audio-video service such as video conferencing, it is necessary to have multicasting, as I mentioned, and it will require sometimes translation, because all users may not be equally capable. So in some cases, the bandwidth of the signal has to be reduced so that some users can take part in video conferencing, or in some situations mixing has to be done. Signals from a number of places are to be mixed. Then they can be aggregated and sent to another place. So these facilities are necessary for video conferencing. And as I mentioned, TCP is not suitable for interactive traffic, and we have to use multicast services of IP, which I have discussed, and use of services of UDP along with RTP, which is another transport layer protocol RTP use. So UDP along with RTP is commonly used to support video conferencing. And the last application that we shall discuss is voice over IP, which is essentially internet telephony. We are very familiar with our telephonic conversation through public switch telephone network. This is essentially a circuit switch network. Now the similar kind of services are being provided through internet, which is known as internet telephony, and this has been made possible with the increased deployment of high speed internet connectivity, and a growing number of individuals are using internet. Because of this, a growing number of individuals are using internet for voice telephony. And two protocols I shall discuss which have been developed to support voice over IP. One is known as SIP, Session Internet Protocol, another is H.323. These two are used to support voice over IP. First, let us consider SIP. SIP can send different types of messages like invite, acknowledgement, buy, options, cancel and register. Each message has a header and a body. For example, to set up a connection, the client, here is the client and here is the server. It sends it can be, instead of writing client and server, let me say this is one terminal and this is another terminal. They want to talk to each other. So this terminal sends invite message and having with address and various options, bandwidth requirement and other thing. Then the other at the other end, the terminal responds with OK message, and it also provides the address. Then this terminal sends the acknowledgement message, and then they can exchange audio. And after the audio conversation is over, the initiator sends a bye message to terminate the communication. So with the help of these three, invite and acknowledge is used to set up a connection, bye is used to terminate a connection, then options are used to negotiate various options, and cancel is used to discontinue of a particular application, and the register I shall discuss about it little later. Now there are different types of address options possible in case of this SIP protocol. For example, one can use IP version 4 address, IP address, or one can use email address, or one can use phone number. Of course, it has to be done using the SIP format. For example, when IP address is used, it has to be SIP followed by colon APAL, then at the rate of say IP address 144, some IP address 144.16.192.110. So this is one address format, or it can be the email address. So this part is same, APAL at the rate of cac.iitkgp.yarnet.in, or it can be the phone number in the SIP format. So there are address can be provided in a number of ways. Then I was talking about the use of register. Particularly whenever we are using DHCP, then a particular user, for example a callee, may not have a permanent IP address. In such a case, to track the callee, the concept of register is used. what is being done? The caller sends the invite address, invite message, which is sent to the proxy server using the email address. It does not know the IP address. Then the proxy server sends, with the help of a lookup service, sends the message to the registrar, and registrar is responsible for holding the information of each of the users. So the registrar replies and provides the IP address. Then the proxy server sends the invite message to the callee using the same IP address, and whenever it sends OK, and that is being communicated to the caller. So proxy server and caller again communicates messages like OK message and acknowledgement message, and finally acknowledgement is sent by the proxy server to the callee, and then the exchange of information can be done, and when the exchange of information is over, the bye message can be sent by the callee. And another protocol, that is your H.3.323, this allows telephone this is used to allow telephones on PSTN to talk to computers. In the previous case, the communication was between two computers. Here we want a telephone, an ordinary telephone has to communicate with another person on the computer. So here you see the public switch telephone network is linked to the internet through a gateway, and another a particular server known as gatekeeper is required, and to support this you require some protocols like compression code, RTP, RTCP, H.225, and for control and signaling Q.931 and H.245. And here how it is being done: a terminal sends a message to the gatekeeper, which responds with the IP address. H.225 message is used to negotiate bandwidth between the caller and the gatekeeper, and then Q.931 is used to set up the connection in the same way as I have discussed. Then H.245 is used to negotiate the compression method that can be used, and RTP is used for audio exchange, RCTP is used for management, and then Q.931 is used to terminate the connection. So you see, you require a number of protocols to support this, which is part of this H.323. And I believe if I don't mention about Skype, which is the most popular voice over IP software that is being used nowadays, voice over service. Skype is a peer-to-peer VoIP client introduced in 2003, and it has been developed by Kaja, a US-based company. It has become very popular, possibly it is having the largest user base, and with the help of this, two people can speak with each other using handsets and microphone connected to computers directly. And it is free between any two computers. However, whenever one wants to talk between a computer and a PSTN line, then of course one has to pay. Skype client can be very easily installed, and within an hour, within few minutes it can be installed and it can be used. Skype has used astonishingly good video compressor, providing very good quality audio. It also supports, in addition to voice, instant messaging, search and file transfer. Moreover, it uses encryption. As a consequence, communication through is secured. Now it is time to give you the review questions. First question is, why compressed video is more sensitive to error than uncompressed video? Second question is, why a media server is used for streamed audio video service? Third question is, distinguish between streaming of stored audio video with that of live audio video. Fourth question is, why TCP is unsuitable for interactive traffic? Fifth question is, what are the key features of SIP protocol? Answer to the questions of question number 1 of lecture number 37. The first question was, why do you need data compression? as I have mentioned, data compression provides the following benefits: reduced storage space, reduced bandwidth of the network, reduced communication cost, and emergence of new applications, as I have discussed today. Second question was distinguish between frequency masking and temporal masking. Answer is, in frequency masking, a loud sound in a frequency range partially or fully masks another sound in a nearby frequency range. On the other hand, in temporal masking, a loud sound can numb our ears for a short duration even after the sound has stopped. So these are the two differences, and these are being used for audio compression in MP3. Question number 3 was compare the importance of luminance compared to chrominance in the context of compression. Answer is, as our eyes are much more sensitive to the luminance signal than to the chrominance signals, so the latter need to be transmitted accurately. So different precision is used for luminance and chrominance. As you have seen, better resolution is used for luminance than chrominance, because luminance is more sensitive to our eyes. So this facilitates better compression. Question number 4 was distinguish between spatial and temporal redundancy. Answer is, spatial redundancy that exists in each frame is used for compression using JPEG. On the other hand, temporal redundancy of a set of frames is used for compression by taking advantage of the fact that consecutive frames are often almost identical. So that is used by MPEG. This is being used by MPEG. Fifth question was, what is motion compensation? As you have seen, differences between consecutive frames of a movie arises because of the result of moving the scene, the camera, or both the frames. The differences are usually very small. This feature can be exploited to get better compression by a technique known as motion compensation, as it is done in MPEG. So with this we have come to the end of today's lecture, and with this also we complete our discussion on multimedia communication. Thank you.